Hello and welcome to Cashmatics. In this lesson, I'll be showing you how to calculate the missing sides and angles in a right-angled triangle using trigonometry. I'll be showing you how to use the famous SOHCAHTOA acronym, and by the end, you'll hopefully be confident with the basics. So grab yourselves a pen and some paper, and let's get started. Now the first thing to note is that this only works with right-angled triangles. Okay, it doesn't work with non-right-angled triangles. For that we have the sine rule and the cosine rule, which you can also find videos of on my channel. Before we begin, we need to be able to label the triangle correctly. Okay, and there's three sides we need to be able to label. The first side is directly opposite the right angle. Okay, and that's called the hypotenuse. So I'm going to just call that hip. Okay, now that'll be directly opposite the right angle, and it'll be the longest side of the right angle triangle. The next side is called the opposite side, and that'll be directly opposite the angle you know or trying to find. Okay, and that's going to be labeled opposite. And the other side is called the adjacent side, which means next to. And the reason why it's called next to is because it's adjacent or next to the angle that you're trying to find or the angle that you know. Okay, so the first thing you need to make sure of is that you can label the triangle correctly. The next thing is to understand this acronym SOHCAHTOA. Now the S, the C and the T stand for sine, cosine and tangent. Okay, and the way it works is this. The sine of the angle, so sine x, you never write sine on its own, sine has to be with an angle, in this case it's x, is equal to the opposite side divided by the hypotenuse. Okay, the cos of the angle, so cos x, would equal the adjacent side divided by the hypotenuse, and tan x would equal the opposite side divided by the adjacent side. So it's really important that you can understand how to label the triangle and also understand how you can use the acronym to get these ratios. Now the other thing you need to know about is the inverse functions. Okay, and these are used to actually find angles. Okay, so you've got inverse sine, inverse cos and inverse tan of the angles. Okay, now the way they work is you need to access those using the shift function on your calculator, shift and then sine, or second function and then sine, okay, or second function and cos, or second function and tan, whichever function you're trying to use. And those are on the top left of your calculator. And if you need to, you can find a manual which will tell you exactly how to use it for your particular calculator. But make sure you know how to use your calculator correctly. Okay, and the other thing to make sure of is that your calculator is in degrees mode. Okay, so it's either going to have a DEG on the top of your display or just a D. Okay, and make sure you know how to change the mode to the correct angle unit. Otherwise, all your calculations are going to be off. So make a note of all this on the screen, and then we'll go and do some examples. So the first thing we're going to do is learn how to calculate missing lengths. Okay, and in these three examples, the missing length is going to be in the numerator. Okay, it's really important that you pay attention to that. And the way it works is this. You first of all label the side that you know. Okay, so in this example down here on the bottom left, we know the side which is opposite the right angle, that's the hypotenuse, so that's the longest side. And then you label the side you want to find, so that's the one next to the angle, so that's the adjacent side. And then we use a trig function which includes both. So over here, where it says SOHCAHTOA, I'm looking for one of the functions that's got the adjacent and the hypotenuse, and that's that one there. Okay, so that's the cosine function. And the way I write it out is this: the cosine of 40 degrees. Remember, cosine has to be written with the angle. Okay, so that's the angle. Cos 40 equals the adjacent, which is x, divided by the hypotenuse, which is 13. Now, I did say we're finding an unknown in the numerator, and that's what's happened here. Okay, so the unknown quantities in the numerator. So all I need to do is get rid of the 13 from the bottom here by multiplying the other side by 13. So 13 times cos 40 is equal to x, and I just type that into my calculator. And that gives me 9.9585, and if I round that to one decimal place, it actually works out to be 10.0 centimeters. Okay, remember when you're rounding to one decimal place, the number after the decimal point must be included. Okay, right, let's move on to this example in the top right. So the side that I know is the hypotenuse. The side I'm trying to find is opposite the 70 degrees, so that is the opposite side. And hypotenuse and opposite appear in this ratio here, so this one here, so the sine ratio. Okay, so I've got sine 70 equals opposite, which is y, divided by the hypotenuse, which is 8. Okay, so I need to multiply the other side by 8, so 8 times sine 70 is equal to y, so y equals 7.5 centimeters. Okay, and lastly down here, let's have a look. We've got the adjacent side, so the side next to the angle, and we're trying to find the side opposite the angle. And opposite and adjacent, that's the tan ratio, so opposite and adjacent is over there. Right, so we have tan 30 equals the opposite side, t, divided by the adjacent side, which is 18. So 18 multiplied by tan 30 is equal to t, so t equals 10.4 centimeters. Okay, so hopefully with those 3 examples you've seen how it all works. Pause the video and make some notes if you need to, and then we'll go on to do some questions. So here you are, 4 questions for you to try. Pause the video and I'll put up the answers in a bit. So I'm about to reveal the answers in 3, 2, 1. There you go. Okay, so check against my solutions, make sure you've labelled your triangles correctly. If you've made any mistakes, see if you can spot where you've made them and what your misconceptions were, and then we'll move on to something slightly different. So here we're going to find an unknown side again, but this time the unknown side is going to be in the denominator. So as before, we're going to label the side that we know, so this is the opposite side. And this is the hypotenuse. Okay, it's the longest side, it's opposite the right angle. So opposite and hypotenuse, that means we're going to use the sine ratio. So let's start it off as before. So sine 31 degrees, let's write that 31 a bit neater, 31 degrees equals the opposite, which is 7, divided by the hypotenuse, which is d. Okay, so when I meant the unknowns in the denominator, that's where it is, it's in the denominator. So I need to treat it just like before, I need to get rid of it from the denominator. Okay, so d multiplied by sine 31, okay, equals 7. Okay, but the thing is, I still haven't got that length on its own. So what I need to do now is divide through by sine 31. So d would equal 7 divided by sine 31 degrees. And then I type that into my calculator, and I get 13.6 centimeters. Now, if you did do this wrong, your answer is not going to be quite right, in the sense that the hypotenuse we know has to be the longest side. So if you did 7 times sine 31, you'd get an answer smaller than 7. Okay, and that can't possibly be the hypotenuse. So it's always worthwhile seeing if the answer you're getting actually makes sense in the context of the question. Right, let's go on to the second one over here. So the side I know is the opposite side. The side I'm trying to find is the adjacent side. So adjacent and opposite, that's this one over here. So that's the tan ratio. So tan 66 is equal to the opposite over the adjacent, which in our case is E. So as before, E times tan 66 is equal to 12. So E equals 12 divided by tan 66, which is 5.3 centimeters. And lastly, let's have a look what we have here. We've got the hypotenuse over here, and this is the adjacent side. And what we need to do is look for the right ratio. So adjacent and hypotenuse, that's this one here, that's the cos ratio. So we've got cos 35 degrees is the adjacent divided by the hypotenuse, which in our case is f. So f times cos 35 is equal to 9. So f is equal to 9 divided by the cos of 35 degrees, which is 11.0 centimeters to 1 decimal place. Okay, so hopefully that's made sense and you've been able to see the difference between these and the last lot of questions that we did. So pause the video, make some notes, and then I'll put up some questions for you. Right, so 4 questions for you to try, but I have thrown in a trap in one of these questions, so please don't fall for it. Think carefully about what you're doing and pause the video, and I'll give you the answers shortly. So answers are coming up in 3, 2, 1, and here they are. Okay, so the trap was actually this question here. Okay, the actual unknown value was in the numerator, so we had to do these in the same way. We did the first lot of questions. So hopefully you didn't fall for that trap, and if you did, just make sure when you do it in future, you look out for it. Right, and there's one last thing to do now, and that is finding an angle. Okay, and I think this is actually the easiest of all the things to do. But let's just have a look. The first thing you need to do is label the 2 sides that you know. Okay, you have to know 2 sides in order to work out an angle. And then you need to use the inverse of the trig function, which includes those 2 sides. Okay, and I'll show you what I mean by that. So let's look at the sides that we know. So here we've got the opposite side, and here we have the hypotenuse. Okay, opposite and hypotenuse means we use sine, but we don't use the inverse function just yet. We just say sine x, that means the sine of this angle x. Remember, you can't just write sine on its own, equals, now is opposite divided by hypotenuse, so that's 7 divided by 9. Okay, remember this fraction here means 7 divided by 9. So to work out x, now at this stage I can get rid of my sign, but in order to do that I need to do the opposite of that. To get rid of something you do the opposite. So that would be the inverse sine of 7 divided by 9. Now some people like to type it in as 7/9 on the calculator, but I think it's just quicker to type in 7 divided by 9. So make sure you open your brackets. Some calculators open the brackets for you. Okay, some you'll have to open yourself. So do the inverse sine of open bracket 7 divided by 9, close your brackets and press equals, and you should get 51.1 degrees. Okay, let's do one more over here. So this time we've got the opposite side, and over here is the adjacent side. Okay, so opposite and adjacent means we use tan. So tan x is the opposite divided by the adjacent, so 10 divided by 3. So x would equal the inverse tan of 10 divided by 3, which equals 73.3 degrees. And one last one, let's see what we have here. We've got the adjacent side here. We've got the hypotenuse here. Okay, so that's the cosine. So cosine x, cos x, equals 11 divided by 14. So x equals the inverse cos of 11 divided by 14, which equals 38.2 degrees. Okay, so make some notes from there if you need to, and then we'll move on to some questions. Right, so here we are, 4 questions for you to try. Make sure you label your sides properly, and remember we're using the inverse function once we've worked out what needs to be divided by what. So pause the video and I'll put up the answers in a little while. Right, so here are the answers in 3, 2, 1. Okay, so check those against your answers, and also, as always, you know, if you've made any mistakes, just see where you've made those errors. Now at the start of the video I did say that this is limited to right angle triangles, and it is, but you might get questions which don't have a right angle triangle in them. But what you can do is split the triangle down the middle in the case of an isosceles triangle or an equilateral triangle to turn it into a question that then does have a right angle in it. So you can still apply SOHCAHTOA in a question which doesn't have a right angle by turning it into a triangle which does have a right angle. And that, together with the sine rule and the cosine rule, which you can also find on my channel, should give you all you need to know to work out the missing sides and angles in any triangle. And that's all there is today, and hopefully I'll see you next time. Goodbye for now.